What if your dog's frantic pacing or your cat's sudden disappearance wasn't just random but a life-saving warning? Across history, animals have been nature's unsung heroes, sensing disasters before they strike. Could your furry friend hold the key to survival? Let's uncover the truth. Nature's alarm system. It's a story we've all heard. A farmer notices his cows acting erratically, or a birdwatcher observes an eerie silence in the skies. Hours later, disaster strikes. Is this just coincidence, or do animals possess a hidden ability to sense impending danger? Throughout history, countless accounts have described strange animal behavior preceding earthquakes, tsunamis, storms, and even volcanic eruptions. These anecdotes, spanning continents and centuries, raise a fascinating question. Are animals nature's alarm system? Or is this phenomenon rooted in myth and selective memory? As scientists race to decode these mysteries, let's delve into the historical, scientific, and anecdotal evidence surrounding this enigmatic topic. Timeless tales of animal instincts. The idea of animals predicting disasters is as old as civilization itself. Ancient texts describe how animals seem to sense catastrophes before humans. In 373 BC, Greek historians recorded that rats, snakes, and weasels flooded the city of Hellite days before an earthquake leveled it. Similarly, during the eruption of Mount Vesuvius in AD 79, Roman observers noted unusual behavior among dogs and birds prior to the disaster. These tales continued into modern times. In 1975, before the Haicheng earthquake in China, residents reported snakes emerging from hibernation in freezing conditions, a bizarre and unnatural occurrence. This behavior, alongside reports of restless livestock, prompted authorities to evacuate the area, saving thousands of lives. The 2004 Indian Ocean tsunami. The Indian Ocean tsunami of 2004 provides one of the most compelling examples of potential animal foresight. As the tsunami approached, villagers in Sri Lanka noticed elephants heading to higher ground and dogs refusing to go outside. In Thailand, some tour guides reported water buffalo running inland, while birds abandoned their usual feeding spots along the coast. Strangely, very few wild animals were found among the casualties of this disaster. Scientists theorize that animals might have detected the subsonic vibrations caused by the undersea earthquake that preceded the tsunami. Others suggest changes in air pressure or magnetic fields could have alerted them. While these theories are plausible, they remain speculative, requiring further study. Earthquakes. Can animals feel the Earth's warnings? Among natural disasters, earthquakes are perhaps the most closely associated with unusual animal behavior. Earthquakes strike without warning, making reliable prediction a scientific holy grail. Animals, however, might sense subtle precursors that humans cannot detect. A study in Japan examined incidents of strange animal behavior before earthquakes and found anecdotal evidence of agitated pets, restless livestock, and abnormal bird migrations. However, it concluded that such behaviors were inconsistent and not predictive enough to serve as a warning system. In contrast, a study using GPS-collared cows and sheep in Italy found that animals exhibited increased movement in the hours before earthquakes, particularly near fault zones. These findings suggest that animals may indeed respond to subtle environmental cues, though the mechanisms remain poorly understood. How do animals sense disasters? If animals can sense disasters, how do they do it? Scientists have proposed several theories to explain this phenomenon. Seismic vibrations. Animals, particularly those with acute hearing or sensitivity to ground vibrations, might detect low-frequency seismic waves that occur before an earthquake. For example, elephants are known to communicate through infrasound, which could also allow them to sense distant quakes. Electromagnetic fields. Changes in the Earth's electromagnetic field, which sometimes precede earthquakes, might be perceptible to certain species. Birds, for instance, use magnetic fields for navigation, and their sensitivity might extend to detecting anomalies caused by tectonic activity. Chemical signals. Before earthquakes, gases like radon may escape from underground fissures. Animals with a heightened sense of smell could potentially detect these changes, though this theory remains speculative. These mechanisms, if proven, could explain why animals sometimes react to disasters before humans are aware of them. However, scientific consensus is still lacking. Hurricanes and tornadoes. Stormy behavior in animals. Beyond earthquakes, animals have displayed unusual behavior before hurricanes, tornadoes, and other severe weather events. Birds, for example, are particularly sensitive to changes in air pressure, which often precede storms. During Hurricane Sandy in 2012, researchers observed that migratory birds altered their flight paths to avoid the storm's path. Similarly, during tornado season, farmers frequently report erratic behavior in livestock, such as cows clustering together or horses becoming unusually skittish. Dogs and cats are also known to exhibit distress, often hiding or whining before storms. These behaviors are thought to result from their ability to detect barometric pressure changes, wind patterns, or even distant thunder. Volcanoes. The quiet warnings of wildlife. Volcanoes are another natural phenomenon where animals might offer clues, often providing subtle warnings before catastrophic eruptions. Before the eruption of Mount St. Helens in 1980, locals reported deer and elk leaving the area en masse, a behavior that was unusual enough to draw attention. Similarly, during eruptions in Indonesia, villagers observed birds and monkeys fleeing volcanic regions days before activity increased, abandoning their habitats long before visible signs of danger appeared. Scientists theorize that animals might detect subtle ground vibrations or tremors that are precursors to eruptions. Additionally, increased temperatures in the environment or the release of volcanic gases like sulfur dioxide may trigger distress in sensitive wildlife. These behaviors, though not foolproof, highlight how animals might react to changes in their surroundings, providing valuable hints when combined with modern monitoring equipment and geological data. The role of technology in decoding behavior. Advances in technology have opened new doors for studying animal behavior, offering tools to explore the link between wildlife activity and natural disasters with unprecedented precision. Projects like International Cooperation for Animal Research using space aim to monitor global animal movements via satellite, creating a vast dataset of behavior patterns across species. By tracking anomalies in migration routes, sudden shifts in movement, or mass evacuations, scientists can identify correlations with natural disasters such as earthquakes, hurricanes, and volcanic eruptions. For instance, a sudden mass exodus of birds or the uncharacteristic migration of animals from one region could signal environmental disturbances, including seismic activity. Similarly, GPS collars on livestock and wildlife allow researchers to monitor activity levels in real time, offering a chance to study how animals respond to subtle environmental shifts. Though still in its early stages, this approach has the potential to integrate animal behavior into disaster prediction systems and improve early warning capabilities for communities. Skepticism and the challenges of interpretation. Despite compelling anecdotes and the promise of emerging technologies, skepticism remains strong within the scientific community regarding the predictive abilities of animals. One major criticism is the lack of consistent, reproducible evidence across species and regions, making it difficult to establish a universal link between animal behavior and natural disasters. While animals might occasionally behave strangely before such events, their actions are not always reliable indicators, leading many experts to view the phenomenon as coincidental rather than predictive. Additionally, many reported behaviors could have alternative explanations, such as the presence of predators, changes in food availability, illness, or environmental stressors unrelated to disasters. Scientists also point to cognitive bias. Humans are more likely to remember and report unusual animal behavior if it coincides with a disaster, creating a misleading association. To overcome these challenges, researchers emphasize the importance of large-scale, long-term studies to eliminate bias, track patterns objectively, and move closer to understanding the true nature of these behaviors. A mystery worth exploring. The question of whether animals can predict disasters remains one of nature's most tantalizing mysteries, capturing the imagination of scientists and laypeople alike. While anecdotes and emerging research suggest a possible connection, scientific evidence is not yet strong enough to draw definitive conclusions or establish a universally reliable framework. However, the potential benefits of understanding this phenomenon are immense and could revolutionize disaster preparedness worldwide. If animals can indeed sense disasters, their behavior could serve as an invaluable early warning system, saving countless lives and minimizing the destruction caused by natural catastrophes. As technology advances and research continues, we may one day unlock the secrets behind this enigmatic connection and harness it to protect vulnerable populations. Until then, it's worth paying attention to the animals around us. They might just know something we don't and could hold the key to nature's most sophisticated alarm system. The mysteries of animal behavior and their connection to natural disasters are as fascinating as they are crucial. If you've enjoyed exploring this video, don't forget to like this video and subscribe for more intriguing insights into nature's wonders. Let's uncover the secrets of our world together, one story at a time.